this is a talk that is all about innovation in the health technology space, innovation in physiatry in general. And what I hope to achieve here is how you can really look for opportunities for innovation in your own practice every day. So I'm going to share a little bit about my story, how I found myself at Mount Sinai, and the sort of work that we do within our division of rehabilitation innovation, which has come to us here at Mount Sinai through the leadership of Joe, and is quite a special division that not a lot of hospitals or health systems around the country or the world have. So, as Joe mentioned, I did a lot of my early work in Australia. I actually grew up in Western Australia, which is down here in the bottom left corner. I first trained as a physical therapist, and from the outset, working as a physical therapist, I was very intrigued both working with high performance athletes, such as the person you see here, who's an ultra endurance cyclist, Rebecca Rush, all the way through to individuals who are recovering from stroke, spinal cord injury, traumatic brain injury. I think from the beginning of my career, this is something that I've always seen as linked, that many of the techniques that we were using to facilitate neurological improvements in people with a brain injury were things that we could exploit in athletic performance to get a little bit more out of an athlete. So this is something that I was always interested in, both ends of the spectrum, but I initially found myself really struggling with conventional and traditional therapy frameworks and practices, because it never seemed very evidence-based to me. It seemed like, especially in brain injury and human performance work, you would go to a place and you would be told, this is the way we do it here. And you would say, well, evidence, science, etc. And people would say, no, this is the way we do it here. So that led to a bit of a clinical crisis for me. Did what everyone does in a crisis, of course. You just go back and do more study because, of course, it solves everything. If you're ever in crisis, go do a PhD. It's a really good way of dealing with your problems. So I went and did my PhD. And I was really fortunate. I had two incredible mentors, Shomo Ghosh and Frank Nastalia, who were both very passionate neuroscientists and neurologists. And I completed a PhD in basic science, trying to understand how the brain produces voluntary movements. This did not solve all of the world's problems. It did raise a whole lot of other questions. And at the end of my PhD, I was, asked to, I was doing the sort of academic thing, which was after your PhD, you go and find a place to postdoc. Now, problem with me was I was living in Australia. Australia is a nightmare place. Trust me, you don't want to stick around for too long because something's going to get you. So I was really fortunate to be offered the opportunity to go and work for Emory Brown at Harvard and MIT and Mass General Hospital. Emory is this sort of incredible human being who somehow managed to juggle being a full professor of medicine at Harvard, a full professor of statistics at MIT, the chair of anesthesiology at Mass General Hospital, all rolled into one, whilst always making time for like young postdocs like me that didn't really know anything. So it was a real pleasure working with Emory for 2 years. He ran a neurostatistics lab, which was really novel at the time. And we were developing computational models in neuroscience. To be really clear, I was never, I'm not really, I wouldn't call myself a data scientist. I wouldn't call myself a data engineer or a coder. But one of the things that I think is important along the way of creating a journey that turns you into an innovator is what I like to call just being bilingual. So I started off as a clinician and I learned to speak clinical. I did a PhD and I learned to speak research. I came into Emory's lab and I knew pretty much from the first month that I wasn't going to be able to do a lot of what his people were doing, because it'd taken them 15 years to learn the math, to be able to develop the algorithms that they were developing in real time. We were watching innovation in this space happen. But I did learn how to have an intelligent conversation with these statisticians. I learned to speak computational neuroscience, computational biology, well enough, I would call it broken, was my fluency, but I could ask for things that made sense. And they made sense to me from a physiology and clinical standpoint, which was a complete mystery to these computational neuroscientists who were just churning out algorithms and not really worrying about the physiology side of things, or if these algorithms that they were developing made biological sense. So it was a really great partnership. I had a lot of fun times there. And then after a couple of years, the experimentalist in me was getting itchy. And so I joined a lab at NYU that was focused on brain-computer interface. We were working on a super exciting project. It was DARPA funded, so Department of Defense was funding it to really accelerate the pace of brain-computer interface research. The idea was we were trying to get non-human primates to gain high-dimensional control of a virtual prosthetic upper extremity. So, getting a monkey to be able to think about moving a prosthetic and getting the prosthetic device to reach out and grasp and do all the things that a functional arm would do. What was really interesting about working in this lab, it was a sprint, and we were very much really trying to hit these deliverables. For anyone who's ever had Department of Defense money, it's hard money. You need to really hit deliverables every single week to keep the money tap on. Otherwise, if you don't hit those deliverables, they just sort of switch it off. And what was interesting about this project was at the very end of it, when we hit the last deliverable, the principal investigator who was working, I was working for at NYU, kind of danced into the room and he said, "Hey, everyone, we've just cured paralysis." And I remember sort of sitting there, the only clinician in the room. I really loved the team that I worked with, but they were all engineers. And they all assumed that paralysis was a problem that you could engineer a solution for. And so, I remember sitting in this room kind of horrified that this guy was making this statement that we had cured paralysis, when all I could think as a clinician was, this implant is never going to go on a human. The computational modeling that we're doing will never not need 5 or 6 supercomputers in a room, which is still the case. We'll never not need 5 or 6 supercomputers in a room to push it forward. And there are issues with the external hardware. There are issues with the longevity of the implants. All sorts of clinical problems that, in my mind, were insurmountable. But in an engineer's mind, it didn't matter. We had hit the deliverables that DARPA had told us to hit, and therefore we had cured paralysis. So that was the first time I saw a real disconnect. This was the second time in my career I was seeing a disconnect that was problematic. I'd already done a PhD. I wasn't going to go into crisis and do a second PhD. That would be crazy. So, I was kind of stuck on what I was going to do. At the time, I attended a conference. It was, one of my human performance buddies invited me to go to this conference and just try and get reintegrated into the world of human performance. And I was really fortunate to hear a speaker by the name of Michael Salonius, who was a clinical chaplain who worked with a lot of folks who were, really struggling with PTSD, veterans who are struggling with PTSD. And someone was asking him about, why can't we just have an AI or a machine learning model come in and handle all of these people who are in crisis, as opposed to a chaplain who is quite limited in their bandwidth. And, in his response to that thing, he said something that really sort of shot me, from the audience, which was, he said, "Progress for the sake of progress is the ideology of a cancer cell." And what I took that to mean, as it blew my mind, what I took that statement to mean was the idea of just advancing technology for the sake of advancing technology without centering the patient, without thinking about community co-design, without thinking about, is this a solution that is going to help us? We're just doing this thing because we've got an AI or a machine learning algorithm, and let's just see how it goes. That is never going to solve anyone's problems. It's only going to compound problems, and it's not the right way to think about technology. And what I realized was a lot of the translational labs that I was working in were thinking this way. They were just like, we just need to get the NIH money, and we need to, don't worry about if this will actually ever help a person, just worry about, can we get the grant? And to get the grant, we need to be doing the next thing and the next thing and the next thing. And don't worry if any of our solutions ever get, uptaken by clinical medicine. So, I'm all for never criticizing something without a solution. So, I wanted to come up with a solution. I didn't want to just complain that the whole system is screwed and we can't do anything and that's it. So I started to think, okay, well, what would a solution look like? What is everyone doing, and what can I do differently? And so the first thing that really popped into my mind was the fact that everyone, 99% of people in academic medicine are doing this. When Matt might publish this paper and publish this figure, believe it or not, this is supposed to be, and I actually can believe it myself, this is supposed to be aspirational. This is supposed to say, hey, you're doing a PhD and you're going to just incrementally advance our scientific understanding. It's not going to be disruptive. It's not going to be, changing the face of knowledge. Incremental innovation, and just go step by step, be slow, be steady, and make it there. And I never, please do not take away from this talk that I have a problem with incremental innovation. That is not what I'm saying. What I am saying is it is wholly inappropriate for us to think that this is the only way that science should happen. It is really sad and detrimental to our patients to have 99% of the science we do funded in this model. That's what I'm saying. That we need more of a balance between incremental innovation, disruptive innovation. So this was the first thing. Everyone was doing this. I was like, okay, so incremental, got it. No one was thinking about impact-oriented research. So no one was thinking about designing experiments that can immediately be useful to patients. What we get told, what we get hammered over and over again is placebo-controlled, randomized controlled trial with stable effect sizes, gold standard outcome measures, and make sure that your inclusion criteria are so narrow that you can absolutely be sure that the effect sizes you're seeing are related to the intervention and not some other, some other variable that could be impacting, the intervention. What this does is it creates clinical trials that are not pragmatic, that are not immediately scalable to a larger population, and therefore take a very long time to translate into meaningful changes in clinical practice. And although we now have techniques, advanced statistical modeling techniques, that can actually allow us to do pragmatic clinical trials, and all of the smart people in the world are doing pragmatic clinical trials if they want to immediately move into clinical practice, we still get stuck in the model of doing pragmatic clinical trials is not the most scientific way, or not the cleanest, or my personal favorite, because the NIH use it all the time. It's not an elegant clinical trial. Whenever you hear elegant clinical trial, let me assure you, that means that clinical trial will never be useful to a patient. It means that they stripped away all of the things that made it broadly applicable to a patient population, and they nudged an incremental innovation. So that was one of the other things. Now, the final thing that I noticed was academic medical centers were wildly siloed. And not only were they wildly siloed by departments, but the departments were actually in direct competition with one another. And then often, even within your department, you would have competitors. Now, they wouldn't come out and say, hey, I'm your rival or I'm your competitor, but they would, keep you out of projects, or they would, do projects without telling you to sort of advance their own work without advancing your own. So there was no team science occurring. And one of the things that I continually am grateful for in this department is the emphasis on teamwork, the emphasis on building good culture over creating a competitive environment where everyone is fighting against one another. But what I really saw a need to do was involve other departments in the work that we're doing as openly and frequently as possible. So this mug shows up on my slides. So I was very unhappily at Cornell trying to build this program, and Joe Herrera heard me speak, and completely ambushed me, brought me in for a meeting early in the morning, which I thought was just a very innocent meeting, and he was like, "Okay, how do we bring you to Mount Sinai?" And I said to Joe very frankly, I was like, "Listen, I'm trying to build this thing at Cornell. I am very unhappily married with Cornell. Like, it's not going well. They want to do things the traditional way. They don't want to do things the the non-traditional way. Why on earth would I pick up everything that I'm doing? Why would I divorce myself from this unhappy marriage and move to Mount Sinai and just get in another unhappy marriage where you guys will probably tell me the same thing? NIH grants, don't do anything innovative, just keep going." And Joe promised me that it wouldn't be that way, and I believed him. And so then he had I had very quickly, I had to be interviewed by Dennis Charney, who's the dean of Mount Sinai, and Dennis started off the interview really sort of cheering for Mount Sinai. He was telling me all of these wonderful things about Mount Sinai. We're the biggest health system in New York City. We win the most grants in these departments. We've got this much money coming in. We're the greatest. And I was sort of sitting there going, okay, like, I get it. I think you guys are really good. And then he switched and he was like, "So yeah, we're the biggest, we're the best, and we're going to be dead in 20 years if we don't innovate faster than our current rate of innovation." And that sort of set me on my heels a bit, because I realized, unlike, at my previous position, I realized I was talking to someone who understood the urgency that we needed to inject into our health systems if we wanted our health systems to survive in their current form. And so he said to me, "Look, Joe likes you. I'm not sold yet. Pitch me an idea that makes me uncomfortable. Pitch me an idea that I think is crazy, and I'll hire you." And so I pitched him the idea of the Abilities Research Center, which is the center that I'm sitting in now, where I said, "You know what? This is going to be an academic medical center that does not write grants. In fact, rather than writing grants, we're going to go out and we're going to solicit companies. We're going to get them to fund pragmatic clinical trials. And then we are going to become pains in the ass to all of the clinicians in our department and beyond to say, this technology works, let's adopt it clinically and get it into the hands of the patients faster than ever." So clearly he liked the idea, because I've been here like 6 years now. But I still had to go through the whole interview process, and I still had to meet folks that had opinions about the idea and didn't necessarily like it. I had traditional track researchers saying, "Oh, so you do research for other people. You don't really do your own research." I had Tech Transfer Office saying, "Well, this is all well and good, but like, what valuable IP can we sell from what you're doing? Like, what is this going to generate that we can sell?" Which is a very Tech Transfer Office thing to say. This is the same song that is sung in every Tech Transfer Office around the country. And the NIH, God love them. I love the traditional track NIH researcher, because they always say, what's your one question? So I don't get it. You're doing all of these different things. What's your single question? Which always makes me laugh, because imagine having an entire research question and entire research career and only asking one question. So my response to all of these comments is, these are very fair comments in our current research infrastructure. They're extremely fair and they make sense, but only when your core mission is bringing in money, it's not patient impact. So when you say my number one is making sure that I remain funded, all of these things become very relevant. They're very front of mind. If you say my number one is patient impact, then it's suddenly not it's not a mystery why we're approaching the model from a different direction. It makes sense. It's like, oh yeah, of course you would open your lab up to the latest technologies that are showing promising clinical trial results, because your mission is to help patients. It's not to have the NIH view you as the leading, the leading expert in X, Y, or Z. Of course, you're not caring about whether or not you or the company keeps the valuable IP, because you just care that the patients get the technology into their hands and the patient gets helped. So flipping what we thought about as the main goal of what we're trying to do, stepping out of the scarcity mindset of, oh, I've got to keep my lab funded, otherwise everything is going to come crashing down. That is what makes the innovation mindset. So I've talked a lot about, how we got to where we are. I want to share a few projects, so you can get a flavor of the diversity of projects that we work on and what we do. One of the things that we have going on in our lab right now is, with the leadership of the amazing assistant professor Laura Tabakoff, we are exploring multiple novel non-pharmacological chronic pain therapies. So clinical trials looking into virtual reality, non-invasive brain stimulation, audio-visual entrainment therapies that can cause sensory disruption to enhance the efficacy of pain therapeutics, and virtual mirror box therapies and other new emerging augmented reality, virtual reality technologies, and non-invasive brain stimulation technologies that can really change the face of chronic pain management. We also are engaging in really awesome research looking into vagus nerve stimulation for stroke recovery. So under the leadership of Dr. Jenna Tosto-Mancuso, we are now implanting chronic stroke survivors with a vagus nerve stimulator. We're following the protocol from a recent, very impactful clinical trial of the technology that showed that chronic stroke survivors could make significant upper extremity recovery gains, by using this vagus nerve stimulation paradigm. To be very clear, this is something that we are testing, and if we see that it is working well in our patients, then we're going to start to really open the floodgates and make this a full-fledged clinical program out of the Abilities Research Center. We also work with outpatient pediatrics through the Charles Lazarus Children's Abilities Center. This is a program that we run every year called Go Baby Go, where it comes under the umbrella of our Therapy is Play program, where we create gamified solutions for kids, either physical or virtual. So this is obviously an example of a physical one where we have built this young kid a car, where we set it up so that his less affected arm does all the steering, his more affected arm hits the accelerator, which is that blue button that you see there. And then you just get to watch his parents panic as they realize that the car goes much, much faster than they thought it was, that they thought it did. And what we get out of this is an engaged kid performing many hundreds of repetitions of a movement that is important to his rehabilitation. What we've seen in Therapy is Play is that when we create gamified environments, if we ask a kid to perform 30 repetitions of a movement using traditional methods, which is a therapist standing with them and saying, hey, do the movement, you maybe get 20 repetitions. If you use an adaptive Xbox controller and put in the latest Paw Patrol game, you get 3,000 repetitions of a movement. So the idea is that we can use these gamified environments. We can create therapy that is fun to get many, many thousands of repetitions out of a kid, which vastly increases the dosage of therapy that we're trying to achieve, and also makes it easy for the parents, because the kid is actually asking to play as opposed to being forced to do the therapy. We have a very advanced exoskeletal robotics program where we simply just make these technologies available to our patients. This robot that you see here is the EXO, EKSO, but we work with many other types of exoskeletal robotics. This particular model is an example of a technology that our lab has taken from running clinical trials with the company all the way through to us becoming a client to the company and saying, you know what, you don't have anything else to prove with your clinical trials. We're now going to pay you for the technology so that other people can see that we're uptaking the technology, and hopefully that creates a trend for other health systems to also invest in the tech. This is the brain-computer interface technology that Joe was referring to earlier. It's a technology called a stentrode. So it is an endovascular stent that is placed in the superior sagittal sinus, right by the primary motor cortex. And what happens when we place it in that location is it can record brain activity around that is centered on motor intention. So when a person who is locked in with ALS thinks about moving their left foot, we can map that signal that is produced as they think about moving their left foot onto a keystroke or a mouse button press in the real world. So the goal of this project, and as Joe mentioned, we've now implanted our second patient, is to allow a person who is fully locked in with paralysis of any sort, spinal cord injury, stroke, ALS, MS, you name it, to gain cognitive control of a personal computer so that they can gain some more independence in their life. On the high performance side, we do a lot of work, as Joe mentioned, with the Brooklyn Nets, with Red Bull, and we learn a lot from that that vantage point. So this was one of the first projects that we had the opportunity to contribute to with Red Bull. This is Red Bull Stratos, where we worked on building good team dynamics between Felix, who's the guy here about to jump out of a spaceship and parachute back to Earth, and the team that was keeping him alive while he did that. So team dynamics is something we focus on a lot and we think about a lot because, without it, this project absolutely wouldn't have happened. And it has always impressed me how things that seem like an individual event or an individual sport in high performance sports can really be a team effort. So, a professional skydiver, you'd think it's all on him, but no, there's a team of people on the ground making sure that this guy can actually parachute himself back to safety without something going catastrophically wrong. And this was one of the first projects we worked on, but we also work on terra firma as well. So we work with a lot of high performance endurance athletes looking at what we were doing in this particular project. This was Project Endurance 3.0. We worked on all of the Project Endurance projects, but this was looking at VO2 max and lactate threshold levels in endurance athletes, both in a sort of a zero altitude, and then we flew them up in a plane to sort of 7,000 feet and looked at how their performance changed with altitude and how we could utilize that in periodizing training. We recently completed and published some work looking at brain activity in big wave surfers. So try and understand how this guy, who's a Red Bull sponsored surfer on a 100-foot wave in Portugal, how his brain is different in the face of threat and threatening images to a regular wave surfer who is also Red Bull sponsored, also has a similar skill level to this individual, but would never in a million years jump on a 100-foot wave like this because he's like the rest of us and sane. So trying to understand what goes on in these in these high performers' minds as they take on a challenge like this is something that we're really interested in, because it leads us to enhancing our ability for talent selection at an earlier age. It enhances our ability to train certain traits that are important. And if you look this paper up, if you sort of search my name and big wave surfers, you can see that we did see some concrete differences in the way that big wave surfers process threat and regulate threat compared to their regular wave cohorts. So it was a very interesting study. I often get asked how we select all of these projects because it seems like there's not a lot of method to the madness. And And really, it's all about answering one question. Do we think that the technology has the potential to be disruptive? So we have a lot of companies reaching out to us now, now that we've set up shop and we've gotten some level of notoriety in what we do. We have a lot of companies reaching out to run clinical trials. What we look for is a disruptive capability to the technology. So I'm not so much interested in running yet another trial on a technology that we already know is pretty good and we just need to sort of get it off the ground. What I'm interested in doing is running a clinical trial that has a disruptive element to it. We're testing a new billing code that if the billing code works, everyone in the hospital can use it and it will change clinical practice. We're implanting a brain-computer interface that enters the body through the blood vessels rather than directly through the brain. Because if we can do that, every endovascular neurosurgeon on the planet knows how to place a stent, and a few cardiologists. Let's not leave them out. So really, when we look at technologies, when we evaluate them, that's what we're looking for. Is this going to be disruptive? Otherwise, we pass it on to our friends and we say, this is an incremental innovation project. It's not what we do, but it still is cool and it still has potential and someone else should run it. So I'm going to finish up with a bit of a sort of final conversation on our guiding principles. So you got to how we started, we've gotten to what we do, and now, why we do it and what's behind what we do, I think is the next important thing to talk about, because again, I want to be really clear that what we do is intentional and we do think about it very deeply before we engage in projects. So our first guiding principle is that health innovation just takes way too long. There is a statistic in the United States that to go from bench to bedside, meaning from point of discovery of a technology to the point where it's being used in common clinical practice, takes 17 years. And, the first guiding principle is that is a dumb number. It shouldn't exist. It should be much smaller. And one of our guiding principles is to make that number go down, because right now, as it stands, there are people waiting way too long for health technology innovation that can't access the care that they need because of stupid bureaucratic reasons, not because the technology isn't there. And it also means that promising companies die while they're waiting for this 17 years to get by, which is why this is called the Valley of Death. It's literally called the Valley of Death, but we're not doing anything to make that valley shorter and faster to traverse. The next, the next guiding principle that we strongly believe in is that hospitals and health systems need to work with industry to foster innovation. There is this myth that we embrace that hospitals are really good at producing companies. We need to just get over that. We're not good at it. We're not set up for it. Most hospitals are 501c3s, which mean that we need to license tech out to a tech transfer office, which happens occasionally. 1 in every 10 years, a hospital will spit out a unicorn and they'll say, see, we're good at innovation and we're good at making companies. It's not the case. Companies are good at making companies. And what's really interesting about this is, there are so many people who are very, very focused on NIH funding. And they say, if you want to do biomedical research, you go to the NIH, they're the bank, they've got all the money. And one thing I like to remind everyone of is the NIH has an annual budget of $30 billion to fund both basic science as well as translational biomedical research. The tech startup world, the health tech market in particular, has an annual budget that continues to grow of somewhere around $300 to $400 billion per year that they are actively trying to spend on rapid, pragmatic clinical trials. And yet 99%, as I mentioned, 99% of the folks in the biomedical research world that are attached to universities are looking at the NIH and bemoaning the fact that they don't have enough money, crying about the fact that they need to submit 10 NIH grants to win one. Whereas there's a whole bunch of companies saying, please take our money and run our clinical trials. Money's not the problem. We just need engaged investigators to run the trials because we think we've got something. And hospitals aren't even set up to attach themselves to this much larger barrel of money. And so they just keep going for the NIH dollars. There's also, a slightly more insidious truth, which is many of our university rankings are decided by how much NIH money that you bring in. And so we need to radically take a look at that. We need to radically change that because the innovation is happening in industry. And when the dean mentioned that if we don't innovate faster, we'll be dead in 20 years, this is the reason why, because everyone is still trying to get that NIH money because it's important to the rankings. But on the other hand, there's a whole bunch of groups that are lapping the NIH in terms of health technology innovation because they don't care about rankings. They just care about making something that will go viral and help a bunch of people. So this is a very important guiding principle for us. We're one of the few centers in the country that actually directly and almost exclusively interact with industry. And we're constantly telling other groups to do the same because we're like, hey guys, we can't handle $300 or $400 billion in funding. We keep asking for more space, Joe. How does that go? Doesn't go well. So we're limited. New York State real estate is pretty finite. We need more places around the country to do it. Another one of our guiding principles is simply that rehabilitation and human performance are the same thing. So physiatrists, think about your job not just as working on one of these ends of the spectrum. You are the whole spectrum. And Joe was very visionary in his effort to change our department from Department of Rehabilitation Medicine, which had been for over 100 years, to the Department of Rehabilitation and Human Performance, to really engage with this idea and understand that we can learn truly valuable things to both ends of the spectrum from the other end and everything in between. And not just that, but we should always be thinking about this spectrum as we rehabilitate our patients. We don't want our patients to stop when they get to, okay, I can stand and I can walk. We want them to continue their journey. And we want to get them, we always should be striving to get them to a point where, this is aspirational, but hell, let's say it, to where they say, the stroke was the thing that actually got me to a higher level of performance than I was before my stroke, because my physiatry team, my rehab team pushed me to become more healthy than I was before I got hurt. We draw a lot of inspiration from an old friend of the lab who has sadly passed away, but I will never forget her immortal quote, which is that pigeonholes are for pigeons. Jessie Norman, for those of you who don't know, was one of the most famous sopranos in the world for a long period of time. And she was always criticized, probably because she was a Black woman in the space. But on the surface, she was always criticized for having a range so large that they couldn't categorize her into soprano, alto, tenor. Her range was too large. And so her famous response always to her critics when they criticized her for having a range that was too big was pigeonholes are for pigeons. And we take that to heart as well. It is so easy to look at a solution that could genuinely help one of your patients and to say, oh, that's out of scope for me. That's not what I do. Well, guess what? Nothing that I do in the Abilities Research Center or any of our other centers is what I do. None of it. If I said that about any of the technologies that came in, we wouldn't be running any of our projects. So really reframe what you're doing. Jessie was just interested in being the best soprano and the best opera singer in the world. She didn't care what you called her. The Abilities Research Center, the Department of Rehabilitation Innovation, the Division of Rehabilitation Innovation, we are only interested in helping our patients. We don't care if the technology comes from another specialty or is slightly out of scope for us. We'll learn about it, we'll investigate it, we'll apply it. Probably one of our most important guiding principles is nothing about us without us. We strongly believe in community co-design for all of our clinical trials. We do not run clinical trials without first running the clinical trial by someone in the community who we will either learn something about the clinical trial for, or will benefit from the clinical trial. Because often the things that we think are improvement, or the things that we think are meaningful, are not meaningful to the clinical population. So understanding that community co-design should form the basis of everything you do when you're running clinical trials is super important. Also, with full disclosure, understanding that even if sometimes you can be running a spinal cord injury clinical trial, which is what we were doing here and how we had all of the folks with spinal cord injury in the room, but the target audience is clinicians, not the patients with spinal cord injury. So this room might look different depending on who you're looking to affect change in, but always you should involve people in the field outside of yourself to make sure that you're centering the voices of the people that matter, which is the folks that are going to benefit from the clinical trial. And then finally, I'll end with this last guiding principle and a little short story, which is, no matter what else we do in the Abilities Research Center, our main thing is if someone comes in looking for help, we don't tell them that there's nothing else we can do. We tell them that we're going to look. We tell them that health technology is changing by the day, and there will be a technology that we can apply to their specific problem if we look. And, I have this picture of Chris Scott, who is one of our patients, because I think it really embodies the work that we do. Thanks to one of our amazing faculty members, Angela Riccobono, I learned about Chris. Chris was a professional skydiver who had an accident while skydiving, miraculously survived, but had a very high level spinal cord injury. And Angela is one of the amazing human beings who helps individuals who have been spinal cord injured transition to a new reality, transition to this new identity as a person with a disability. And she contacted me and said, I've got this guy, I don't know what to do with him, but I really think he could benefit from seeing your lab and seeing that there's a bit of hope, seeing that people are working the problem and working on new technologies. So I can never say no to Angela, and if you guys end up working here, you will also never be able to say no to Angela. And so I said yes, and Chris showed up to my lab, and I sat down with him, and I didn't know what to do. It's a high level spinal cord injury, no movement of arms and legs, and I didn't even really know where the conversation was going. So I kind of treated it like, I don't know, a job interview where I was like, oh, well, tell me about yourself. Tell me what you like to do. Tell me, what we could help with. And he starts talking about a few things in his life. And then he really zeroes in pretty quickly on the fact that he loves playing video games. And at this time, this was about 4 years ago, I was, I had seen people play mainstream video games with adaptive controls. In fact, I was kind of known for it. But I had never seen someone with Chris's level of disability playing mainstream video games. I had seen them play special video games for rehab, but never mainstream. And I was like, man, you got to show me how you play video games. And he indicates to his backpack and with his head, and I pull out this amazing contraption that's called a quad stick, which is basically a combination of a head-controlled joystick and a sip and puff mouse. And I sort of set this thing up for him, and he proceeds to properly kick my ass at NBA 2K. So we're playing on Xbox. I'm not trying to tell you I'm the best 2K player in the world, but I am trying to tell you I thought I had this guy. I thought, okay, Chris can't move his arms and his legs. I'm going to make the very ableist assumption that I'm gonna beat this guy. He wiped the floor with me, not even close. And that was when I said to him, it's really unbelievable that you're sitting here, because if you can believe it, about a week ago, we launched this new technology for using facial recognition to control a cursor on a computer for another one of our spinal cord injured patients. And we, just for fun, we developed a little comic book around it. And in the comic book, we've got this guy who has a skydiving accident, who then uses our technology and becomes a badass gamer and starts to become an esports athlete. So I don't know what serendipity brought you into this room right now, but I think we should form an esports team, and you should be the captain. You know, we should run with this. And you know, one of the ways that you know you're onto a good idea is when you reach out to a patient population that typically it takes a lot to get a lot of high-level quads into a room, and suddenly everyone's in the room. That's how you know you're onto a good idea. This is a pre-COVID photo, by the way, which is why no masks. But we immediately had an influx of folks with spinal cord injury who wanted to be part of a team. Sergio, the guy in the maroon hoodie over here, who also had a similar injury to Chris, used a mouth stick to paint the Quad Gods logo. These guys named themselves the Quad Gods, and Sergio painted the logo that we then digitized. They've become a full-fledged esports team. They're actually active out there. They're the topic of an HBO documentary. They're funded by Mark Cuban because he's big in the esports space. These guys are out there kicking ass, taking names. Logitech caught hold of them and have now launched the Adaptive Esports Tournament this is Ujesh Desai, who runs Logitech Gaming Division. And now we're in our third year of an Adaptive Esports Tournament, which is worldwide. We have applicants from every corner of the globe who are disabled, who want to compete in this. And Mount Sinai is one of the founding sponsors. We do all of the intake exams to confirm that someone has a disability and confirm the level of competition that they'll be competing in, depending on the adaptive equipment that they use. And then, you know, some of the Quad Gods, just one of the things that I find really important about all of this is Nairi, who is one of the Quad Gods, and she always talks about the fact that she gained family. So this is an individual who was heavily socially isolated before joining the Quad Gods, and now she feels that she has this whole family open to her about that are you know, engaging in esports and looking out for her and checking in on her on the daily, and giving her you know, giving her social connection that previously she just wasn't able to access through her regular channels. So the thing, you know, that I always just ruminate on when I think about that final guiding principle, and I think about Chris a lot, is that if we were a regular space, if we were a regular rehab gym, if we were a regular rehab department that didn't have an innovation division, thanks to Joe's leadership, this is always 100% leadership focused, and you can't do it without leadership. If we didn't have this, Chris would have knocked on the door. I would have shrugged and said, "There's nothing we can do for you," and that would have been it. That would be what a regular rehab center does. We are not a regular rehab department. We are not a regular center, and this is what the power of having a center or multiple centers now that are focused on innovation. This is the power that it brings, and the possibility that it brings to what we can do for our patients. So I would love to leave it there. I have one final slide because I think it's always really important to acknowledge this. Because I'm always trying to encourage that everyone become an innovator. I really want to acknowledge that a lot of my ability to innovate and ability to take risks comes from the fact that I hold a shit ton of privileges. I am a very privileged person in that, you know, I can take big risks that other people may not be in a position to take. And so always, if you're trying to relate this to your own life, please, you know, please don't tell your supervisor to go screw themselves and quit your job or, you know, do anything completely rash. Please understand that, you know, our ability to absorb risk and manage risk comes from our own general level of privilege. Have an understanding of your own risk tolerance, because you always have risk that you can tolerate, but understand that it doesn't need to be this wildly dramatic risk that you take to innovate. It can be just making 5 minutes for that high-level spinal cord injured patient that wants to do something other than sit in their bed and watch TV, and letting them know, hey, do you know about the quad stick? And giving them information about the quad stick. It can be 3D printing something yourself that, you know, might help out somebody. These are very small steps, but it brings about a whole culture of innovation when everybody does it. So now I'll end, because I've been talking forever and we want some time for questions. But I also just want to acknowledge the fact that I just get to talk about this stuff. There's a whole bunch of awesome people who actually empower me and empower the team to do it. So thank you everyone for listening, and please hit me up with questions.